Hi everyone, it is Việt Hoàng. Today I will introduce you to using Lagrange Multiplier Method to solve optimization problem. It is on chapter 13.10 in our textbook, and the first problem we will work today is problem number 5. Use Lagrange multiplier to find the extrema of the function fxy equal x squared plus y squared given the constraint x plus 2y minus 5 equals 0. So let's work on it. I have two functions written down here, and first of all let's call the constraint function gxy. I will typing as I working along with the problem, so there's some limited on the writing. So for example, instead of drawing the gradient symbol, I will just type capital G, and instead of saying lambda, I will use capital L to represent it. So and I will type down the gradient equation and Lagrange multiplier equation, and we will work with them for the whole of this video. So first of all, we gonna write gradient equation, gonna be g of fxy equal fxy times I, and another limited that I could not able to draw the vector symbol on I and j, and fy of x and y times j. The Lagrange multiplier equation is g of fxy will be equal lambda times g of gxy. So the first step we need to find the gradient of f and gradient of y. This is the very simple equation, so I can go ahead and write the gradient equation directly instead of finding fx, fy or gx, gy. So the gradient of fx y will be equal to 2x times I plus 2y times j, and the gradient of gxy will be equal I times 2j. So let me go step 1. Step 2, we use the Lagrange multiplier equation to set fxy equal lambda of gxy. So it means 2xi plus 2yj equal lambda I plus 2 lambda j. If and only if 2x equal L and 2y equal 2L, from that we get y equal 2h, and from that solution we will go to step 3, replace what we find to the constraint equation. So we have g of xy equal x plus 2y minus 5 gonna be equal x plus 2 times 2 of x minus 5 equal 5x minus 5 equals 0. So x equal 1. When x equal 1, so y equal 2x equal 2. So after step 3, we can say the Lagrange point t 1, 2, and we will replace that point to the function f. F1, 2 equal 1 square plus 2 square equal 5. Let's use the applet to verify the problem. So the applet, they have the given function 4 equal x squared plus 2 squared. We will use that for the f function. So let's add the constraint. Okay, let's write here g x plus 2y minus 5 equal 0, so y equal minus 0.5x plus 2.5, and we will write using that as the constraint in the applet. 0.5x plus 2.5 minus, and let's see, let's make it, and here is the contour plot of the function f and g, and as you see, every we moving it around, you see the gradient of the moving. And at the if you go through the Lagrange exploration, you know that at that point when the two gradients parallel, they are, or when the gradient blue of the constraint in tangent with the contour level of f, they are in the extreme, and we will use that point and continue working on our problem. Let's look again on the applet. It is 1, 2, and 5. The same answer like we find in the problem. So we will choose the point between that. So let's see. Here is the point we have x equal 1, y equal 2. Let's choose the point here of x equal 0 and the point here of x equal 2. X equal 2, y equal about 1.5, but let's use calculus to do that. So let's say if x equal 0, use the constraint function we have, 0 plus 2y minus 5 equal 0, so y equal 5 over 2 equal 2.5, and we have f 0 and 2.5 equal 0 square plus 2.5 square equal 6.25, larger than 5. If x equal 2, then 2 plus 2y minus 5 equal 0, so y equal 3 over 2 equal 1.5, f of 2 1.5 equal 2 square plus 1.5 square equal again 6.25, larger than 5. So we can conclude thus f had a relative minimum of 5 at 1, 2 subject to the given constraint. And that's it. We're done with problem 5 in the homework. One of the helpful hints for that problem is on the contour plot. Here, the relative extreme occur not only when the gradient of f and g parallel and point in the different direction, but it also happens when gradient of f and j point in the same direction, or when the gradient of f equals 0. It will explain pretty well in the exploration, and I hope you figure it out. If not, that is what I give you. Thank you.